Hello everyone, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for sparing time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. This is our channel name, Mathematical Side Trips. In this video, the discussion will focus on the three-point form equation of a parabola. We have a two-point form equation of a line. Now we'll talk about the three-point form equation of a parabola. The equation ax plus by plus c equals 0 represents a line in the plane. If this line has slope m and y-intercept b, then its equation may be written y equals mx plus b, which is called the slope-intercept form of an equation of a line. If this line contains the points x sub 1, y sub 1, and x sub 2, y sub 2, then this line can also be represented by either of the equations y minus y sub 1 equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2 times x minus x sub 1, or y minus y sub 2 equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2 times x minus x sub 2. And either of this equation is called the two-point form equation of a line. The quadratic equation y equals ax squared plus bx plus c represents a parabola. When the values of the coefficients a and b and the constant term c are known, then we have a specific parabola. The values of these three constants can be determined when 3 points on the parabola are known. For example, if p sub 1, p sub 2, and p sub 3 are points on a parabola, then its equation can be determined by solving the system. Okay, this system. So we solve this system for a, b, and c since the x sub i's and y sub i's are given. Consider the following. Find an equation of the parabola containing the points p sub 1 with coordinates negative 1 and 1, p sub 2 with coordinates 2 and 4, and p sub 3 with coordinates 3 and 9. Plugging the values of the abscissas and ordinates into the equation y equals ax squared plus bx plus c, we get the system of equations in three unknowns. Okay, a minus b plus c equals 1, 4a plus 2b plus c equals 4, and 9a plus 3b plus c equals 9. So we have three equations, three unknowns. So we can solve for a, b, c, and a equals 1, b equals 0, and c equals 0 also. Therefore, the parabola has the equation y equals x squared. There is a more direct way of determining the equation which does not involve solving a system of equations. Take note that the given three non-collinear points p sub 1, p sub 2, and p sub 3 in the plane, there are four cases that are possible. First case, if exactly two of these points lie on a line parallel to the x-axis, then the axis of the parabola is vertical. If exactly two of these points lie on a line parallel to the y-axis, then the axis of the parabola is horizontal. If no two of these points lie on a line parallel to either axis, then there are two parabolas that contain these points. One has vertical axis and the other has horizontal axis. And case number 4, or letter D, if these 3 points form a right triangle whose sides are parallel to the x and y axis, then the axis of the parabola is neither horizontal nor vertical, discussion of which case will not be done in this video. The following theorem takes care of case A and half of case C. Theorem: suppose p sub 1, p sub 2, and p sub 3 are three non-collinear points in the plane. Then there is a parabola containing these points whose equation is given by, okay, so y equals y sub 1 minus y sub 2 over x sub 1 minus x sub 2 times x minus x sub 1 plus y sub 1 enclosed in brackets times x minus x sub 3 over x sub 1 minus x sub 3, the whole fraction enclosed in parentheses, and then plus, enclosed in brackets, we have y sub 2 minus y sub 3 times over x sub 2 minus x sub 3 times x minus x sub 2 plus y sub 2 times this fraction enclosed in parentheses x minus x sub 1 over x sub 3 minus x sub 1. And this equation is called the three-point form equation of a parabola. It is called a three-point form because it involves 3 points. And the given abscissas and ordinates of these 3 points are used in the equation. Proof: let a of x be this expression, actually the first part of the three-point formula, and let the quantity inside the brackets be equal to p of x, and b of x be equal to the second part of the equation, where the quantity inside the brackets is q of x. Observe that p of x and q of x are linear in x. Then a of x and b of x are quadratic in x, because inside there is an x and outside there's also an x, so x times x is x squared. So we have a quadratic expression. Necessarily, ax plus bx is quadratic in x. In case A, if p sub 1 and p sub 2 lie on the same horizontal line, then y sub 1 equals y sub 2. and a of x equals the quantity in the bracket, inside the brackets is 0 plus y sub 1 times x minus x sub 3 over x sub 1 minus x sub 3, and which is linear, but b of x is still quadratic. Now, if p sub 2 and p sub 2 and p sub 3 lie horizontally, then y sub 2 equals y sub 3, and b of x is linear, while a of x is quadratic. If p sub 1 and p sub 3 lie horizontally, then both a of x and b of x are quadratic expressions. In case C, if no two of the three given points lie horizontally, then both a of x and b of x are quadratic. In any case, a of x plus b of x is quadratic in x. Therefore, the equation y equals a of x plus b of x represents a parabola. Note that a of x sub 3 equals 0 and y is equal to b of x sub 3, which is equal to this expression here. Which simplifies to y sub 3. On the other hand, when we plug in x sub 1 in the expression for b of x, then it is 0 and y is equal to y sub 1. Finally, when x equals x sub 2, we have y is equal to a of x sub 2 plus b of x sub 2, which is equal to this expression here on the right side, which simplifies to the next expression, which simplifies to this expression, and again it simplifies to y sub 2. Therefore, the 3-point form equation is an equation of a parabola that contains the given 3 non-collinear points. It is not difficult to verify that if you plug in this quantity y sub 1 x sub 2 minus y sub 2 x sub 1 over y sub 1 minus y sub 2 in the expression for a of x, then we get 0. Similarly, if we plug in this quantity y sub 2 x sub 3 minus y sub 3 x sub 2 over y sub 2 minus y sub 3 in the expression for b of x, then b of this quantity is equal to 0. Example, find an equation of the parabola containing the 3 points p sub 1, p sub 2, and p sub 3 using the 3-point form. Notice that the points p sub 1 and p sub 2 lie on the same horizontal line, indicating that the axis of the parabola is vertical. Plugging the corresponding abscissas and ordinates of the 3 given points into the formula, we obtain y equals this expression, which is equal to the next expression, which simplifies to this expression, which further simplifies to x squared. So therefore, those three given points lie on the equation y equals, or the parabola y equals x squared. Now, the parabola y equals negative 3 halves x squared plus 6x minus 2 contains the points p sub 1 with coordinates 0 and negative 2, p sub 2 with coordinates 2, 4, and p sub 3 with coordinates 6, negative 20. Use the 3-point form to confirm the given equation. Okay, solution. Notice that no two of the points lie on the same horizontal or vertical line. So this is case C. That is, there are two parabolas that contain these points. For now, we will just confirm the given equation. That is, only the parabola with vertical axis. So, plugging in the given values, we have this expression for y, which simplifies to the given equation of the parabola. So, we have used the 3-point form to confirm an equation of the parabola, given 3 points lying on the parabola. I mentioned the 3-point form parabolic equation for the first time in a plenary speech given at the 2016 Mathematical Society of the Philippines MSP Caraga Chapter Annual Convention in Rosario, Agusan del Sur, Mindanao, Philippines on November 12, 2016. It turns out that there is another 3-point form that already exists before this date. That will be the subject of an upcoming video. The 3-point form equation of a parabola has some interesting applications. It can be used to model or approximate a scatter plot that is parabolic in shape. Cases B and C and other interesting features of the 3-point form equation will be discussed in the next video. That is all for now. We hope that you have learned something to help you in the practice of the noblest profession in the world if you are a teacher. The next video is a continuation of the discussion about the 3-point form equation of a parabola. God bless.